So hello and welcome everyone. Welcome to this weekly coding contest 195, and I hope your weekly coding contest experience has been good this time. So do write down in the comment section below that how many questions were you able to solve this time, and are you seeing progress in yourself or not. Okay, so I am Jay Dalsaniya and welcome to this post contest analysis of weekly coding contest 195, and here are the solutions of all the interesting questions. So watch this video entirely, and if you really enjoying this video solutions provided by GeeksforGeeks, then do hit the like button and share down your approaches in the comment section below. Okay, so let's start with the first question. So first question says minimum number of operations for full ones, row and column. So this is very interesting problem. So here you will be given a binary grid n cross n which contains zeros and ones. Now you can perform an operation that is switching a cell having 0 to 1. Okay, now your goal is to determine the minimum number of operations required so that at least one row and at least one column in the grid contains only ones. Means you can switch any 0 to 1, and based upon that you are supposed to find out that what are the minimum operations required to make at least one row and at least one column in the grid which has only ones. Okay, so let's see some of the examples to get a better understanding. So here, let's say we have let's say grid something like this: 0 0 1 1 0 0 0. Now here I have to find out what are the minimum operations required to make at least one row with all ones, one row having all ones, and one column having all ones. So here one of the operation which I can see if I change it, so one operation has been done, and if I change this to, then you can see three operations are done. So total operations which I have performed so far is equal to 3 to make all these cells, or let's say at least one row and at least one column having value, having all the values 1. So one answer that we got is 3 for this kind of scenario. And let's see in the test cases what do we have. We have this. Let's see the second example. So in the second example we have 0 0 0 1 0 0 0 and 0 and 0. So now here I have to make at least one row and at least one column containing all the ones. So here I need to apply how many operations. I'll change this 1 to 1. I'll change this 0 to 1. So one row has been conquered, and here I'll change this one and this one. So one column has all ones, I mean one row has all the ones and one column has all the ones. How many ones I made? I made 4 ones. So total operations required by me was 4. And if you see one more example, if we have something like this, and in this we are supposed to find out how many operations are required. So I will change this one. So one column has been containing all the ones, and I'll change this one. So one row also has. So 2 operations are done in this case. So the answer comes out to be 2 over here. Okay, so now let's try to solve this and see how can we find the answer. So for the first example, I would like to first of all calculate that what are the operations required to make ones in the ith row and jth column. So for this row, what are the operations required? 3 operations are required because we have 3 zeros. For this row, 2 operations are required. For this row, 2 operations are required. So let's imagine you have an array called as row, and row of I indicates the number of operations required to make ith row all elements 1. And similarly for column, for this column I need to change 3 zeros, so 3 operations required. For this column I need 1 operation, and for this column also I need 3 operations. So imagine column of j or I represents the number of operations required to make all the jth column elements to 1. Now here we know that any particular cell I comma j. Okay, so let's imagine that if your I comma j is having a value 0, then if you apply an operation, so what effect will it make? So it will basically impact the ith row and it will impact the jth column. If let's say your I comma j is 0 comma 0, so I is 0 and j is also 0, and this cell is equal to 0. If you change it to 1, then total operations which are required, okay, total operations which are required to make ith row and jth column 1 is nothing but, it is nothing but the row of I plus column of j minus 1. Why minus 1? If you see what is row of I, it is 3, means 3 operations to make this entire row 1, plus column of j means 3 operations to make this entire column 1, right? But we have already applied an operation on this shared element, so minus 1 for that, right? Because this cell is considered over here in ith row and jth column as well, so minus 1 for that. So you have 3 plus 3 minus 2, so this would be 5 operations. So if you change this I comma j, that is 0 comma 0 to a 1, then you can have at least one row and at least one column having all zeros. Now if your I comma j is already 1, If your I comma j is already 1, then what are the total number of operations for this one? If you see that this cell is the changing cell, then total operation is nothing but row of I plus column of j, because in this entire row you need how many operations? Two operations to make it all ones, and in this entire column you need how many operations? Only one operation. So total 2 plus 1, 3 operations are required to make at least one row and at least one column having all the values 1. Okay, so first of all we'll find out this row values and column values, and then you will see what will happen, what will be the number of operations if you change any I comma j to 1 if it is 0. So this is the formula. If any I comma j has been changed from 0 to 1, then total operations for ith row and jth column would be this many, and if the cell is already 1, then this is the total operations required. Now let's say the implementation, a very simple implementation. So integer n is equal to grid dot length, getting the idea about the length of the array. Row, how many elements? N elements. Column, how many elements? Number of operations in ith row, number of operations for jth column. Now I'm finding out how many operations. So wherever I see I comma j is 0, row of I indicates increment in the number of operations, and column of j indicates operation increment. Now let's check total operations needed if we change 0 at I comma jth position. To make all ones in ith row, row of I operations are required, and to make all the ones in jth row of j operations are required. Now if I comma j is already, if it is already 0, then what you do, you basically apply operation to make it 1. So total operations done or required will be what? Row of I plus column of j minus 1 for this I comma j which has already gone through one operation. Now I have taken answer with very large value. 2 into n is a very large value, right? So and I will just large value is with respect to this given grid. So the answer will not be obviously 2 into n. In any case, it would be n plus n, or it would be similar to 2n. For I'll iterate over all the elements. If I see grid of I comma j is 0, then I apply operation on this one. Then total operation required would be row of I plus column of j minus 1, and update the answer if this is minimum. Else if it is already 1, then row of I and column j is all the number of operation, and update the answer, and then at the end return the answer, and that's it. Now let's try to submit it. So while it is getting submitted, let's see what is the time and space complexity. So time complexity is over here n square and n square, while if we talk about the space complexity, it is n plus n due to this row and column array. Okay, so this was our first question. Now let's see the other interesting question. So now let's move to the next question. Okay, so now let's solve the second question, that is supermarket. So you are planning to buy n different grocery items from the market, and you have a budget constraint of each item. Specifically, you are given an array budget of size n, where budget of I represents the maximum amount you can spend on the ith item. So on a day, you are supposed to buy n different items, and there is some specific budget acquired by ith item, and that is represented by the array budget. Now there are two shops in the market, and each shop provides the same set of n grocery items but at different prices. So there are two shops, and cost 1 I represents the price of ith item in the first shop, and cost 2 of I represents the price of the ith item in the second shop. Now you can buy multiple items, okay? You can buy an item multiple number of times, and you are supposed to buy n number of items. But the catch over here is that if you are buying an item, ith item, x number of times, then all the other items from that shop should be bought x number of times. So here is the statement: you can buy an item multiple times, but all the items must be bought in the same quantity. That is, if you decide to buy an item x times, then every other item must also be bought x number of times from that particular shop. Now determine the maximum number of days you can stock up on grocery items, considering that each day you need to buy n different items, and for each item the total cost does not exist budget of I. Now it is saying that you are supposed to find out that for how many days you can buy n different items. Maybe you can buy some items on ith day from shop 1, and then you can go to shop number 2 for some days, and you are supposed to find out for how many maximum days you can survive with n items on every day. Now let's start with the first test case which is given to us, and we'll try to find the answer, and let's try to solve the first test case. So here there are three different things. So you will be given the budget that you can have for a particular item. Let's call the budget array, and this is 500 for the first item, then 200 for the second item, 2000 for the third item, and 1000 for the fourth item. Now cost 1 means the cost of ith item on the first shop, it is 200, then we have 50, then we have 500, and then we have 200 over here. Now cost 2 is basically the cost of ith item for the shop number 2. For the first item it is 100, second item is also 100, and the third item is of 400, and the last item, fourth item is of 500 cost. Okay, so now we are here, we can try out different combinations. Okay, so what I will be doing, let's say on day number 1, what you will be doing, you will be going to the first shop and you will be buying all the items once. Okay, so if you buy all the item once on the let's first of all validate whether we can buy all the item once for a particular day. So for the day 1 I will buy all the items once. So here you can see that you have a budget of 500 and 200 is the cost of first item, so you will be having remaining budget after day number 1, imagining that you are buying all the items from the first shop only. So you will be having 300 for the first one, then you will be having 150 budget remaining for the second item, then you will be having 1500 remaining for the third item, and you will be having 1800 remaining for the second item. So on day 1 you are able to buy n different items. Okay, now let's see, on day number 2 you are left with this much of budget, and now this is the remaining budget left for the ith item. And what you will be doing, you will be again saying that let's try to buy all the n different items from the first shop. So this is the cost. Now let's try to see what will be the updates for the budgets in the remaining budget array. So here is the remaining budget, so I can buy the first item. So I'll be left with 100 rupees for the budget of the ith item, then I'll be left with 100 over here, then I'll be left with 1000 for the third item, and then I'll be left with 600. Okay, so I'm buying only one occurrence, or let's say one item. Okay, once, I'm only just buying once ith item. Now this is my remaining budget. And now let's say if I go to day number 3, so on day number 3 this is the remaining budget for the ith item. And now let's try to see whether we can buy from the first shop or the second shop. So if we go with the first shop, you can observe the first item cannot be bought because first shop sells it for 200 and the budget is only 100. So let's go with the second shop. So if you go with the second shop, what you will be having is this as the cost of all the items. And now let's see if we can buy all the items. So there will be some updation in the remaining budget. So here is the remaining budget. So we can buy the first item. Yes, remaining budget is 100. Okay, so this is cost 1 again. I have to copy cost number 2. Okay, so let's copy cost number 2 over here. Okay, now for the first item I can buy the first item, and now remaining budget will be 0. Now here also remaining budget will be 0. Now here the remaining budget is going to be 600, and here the remaining budget is going to be 100. Now this is the remaining budget I have. And if you see if you can buy for the fourth day or not, you can see that some of the budget has already been expired, or let's say it is reduced down to 0, so you cannot buy any other items because you don't have budget of first and the second item. Now you can see that you have been successfully provided with the stock up of groceries for 3 days, and this is the maximum number of days you can buy and different items. So the output for this first example, hence it comes out to be 3, that you can survive for 3 days buying and different items given the budget of each and every item. Okay, so I hope you got an idea that what the question is trying to say. Now let's try to talk about the approach on how we are going to solve this question. Okay, so if we talk about the approach, by far you might have been able to figure out that okay, so this can be some implementations that you can do, because we have seen a very nice dry run of this entire problem statement using a test case. So the approach number 2 says that first what we should be keeping in mind, that okay, let's try to depend particularly on a particular shop. Let's say I will try to find out that how many days I can survive by just buying items from the first shop. Okay, so this is the number of days, or let's say this is the maximum number of days surviving, or let's say shopping from shop number 1. Okay, so now let's say, Lord, what is mn number 1? It is the number of days we can shop from shop number 1. Okay, so this is the maximum number of days we can shop from the shop number 1. And similarly, we'll try to find out a similar value for the second shop. That let's say if we have only one shop and that is the second shop, then what is the maximum number of days we can shop from that second shop given the budget? So mn number 2, and this is for the shop number 2. So let's first of all find out mn and mn number 2. Okay, so this is not exactly the maximum. It is basically an upper bound that, okay, so I'll first of all find the values of mn and mn2 so that you'll get to know about what is mn and mn number 2. So let's try to find out the value of minimum number of days we can buy, or let's say the number of days we can shop from shop number 1. So let's calculate mn number 1. So for that, what I'll be doing, I'll be taking the budget and the cost of ith item from the shop number 1. Okay, now I have to find out mn, that is for how many days straight, how many days I can buy from the first shop. So this mn is nothing but it is the minimum of all the values. Now what is the value? So I want to see that ith item can be bought how many times. So let's say this is the first item. So first item can be bought how many times? So that would be 500 divided by 200. It is, so I can buy around 2 units for this first item. Now let's say to see for the second item how many maximum units can you buy. So that would be 200 divided by 50. You can buy 4 units. Now for the third item, how many times can you buy the third item? So that would be 500, 2000 divided by 500. This also gives you 4. And over here for the last item we have 1000 divided by 200. This gives you 5. Now the question was saying that there is a very important statement in the problem statement. So the question is saying that if you are buying X items, or let's say if you are buying ith item X number of times, then all the items should be bought X number of times. So now here the value of mn1 is going to be minimum of all this. Why minimum of all this? So mn1 comes out to be 2. Means it is saying that you can buy all the n items for 2 days if you have only shop number 1, right? You can survive for 2 days. You can buy for 2 days all the items from the shop number 1, only from shop number 1. So this is mn number 1. Now let's try to find out mn2 similarly. So mn number 2 can be found in the similar way. So it will all make sense if you let me complete the entire explanation. So first I'm trying to find out that, let's say if I'm depending on a specific item, I'm just depending upon a specific shop number 1 or shop number 2, then for how many days can I survive with a particular shop, means for with one shop only. So that would be mn number 2. Now let's say for how many days can I survive by buying all the items from only shop number 2. So this will be mn number 2, mn2, that is minimum of all these values. So I can buy similarly same value I'll be finding out here. So 500 divided by 100. So I can buy this item for how many days? 5 days. Now 200 divided by 100. So this gives you 2. So I can buy this item for 2 days. Now for the third item, I can buy this third item for how many days? 2000 divided by 400. It gives you 5. And now for the last item, I can buy these items for how many days? I can buy this item for 2 days. Now I have to buy all items same number of times. So if I try to buy all items 2 times, because the minimum value is 2, then I can buy all the items. So this mn2 comes out to be 2 again. Okay, so this is the number of days I can buy or spend my entire budget on shop number 2, and this is number of days I can spend my entire budget on only shop number 1. Okay, so now this is not going to give you the most optimal answer. This is not going to give you maximum answer. If you are thinking that let's take maximum of mn2 and mn1, maximum of mn1 and mn2, then this is going to be your final answer. No, this is not going to be your final answer. This is not the final answer. Why is it not the final answer? Because sometimes it is possible that you will buy from a particular shop for, let's say, X, or let's say for some particular number of days. Let's say that value is count 1. So let's say count 1 indicates that you are buying this many number of days you shop from, let's say for example, shop number 1. Then similarly there will be a count 2 that indicates number of days you can shop from shop number 2. So you need to get the value of count 1 and count 2. A mixture of the purchases should be made from the first shop and the second shop. You should not be simply depending upon a particular shop, because if you see the answer that we got over here, so for the first day I was buying from the first shop, from the second day I was buying from the first shop, and on the third day I was not able to afford shop number 1, so I went to shop number 2 and I was able to satisfy my third day as well. So here there was a combination of purchases for ith day. Okay, for particular day I have selected shop 1 or shop number 2. So a mixing of both the shoppings should be done, mixing of both the purchases should be done. So now what I should be doing in order to get the maximum answer? So from now onwards our target will be to maximize the value of count 1 plus count number 2, count 1 and count number 2, so that I can survive for more number of days. Okay, so in order to maximize this value, what I'll be doing, as we know that we can survive 2 days straight if I only shop from the second shop. Similarly, we also know that we can survive for straight 2 days if I only shop from shop number 1. So what I will do, I will try out different number of days starting from 0 to mn1. Okay, that I would find out that, let's say, the count 1 indicates that these are the number of days I can buy from shop number 1, and this largest value possible will be obviously be mn1, okay, which we have already calculated. Now let's try to find out. Let's say what you are doing, count 1, you are saying that count 1 initially is 0, then you will find out what is the value of count number 2, that how many days you can survive by shopping from shop number 2, and how many for this, let's say it is 0. Then you will try out different value. Let's say if you try to survive for 1 day, if you shop for 1 day from shop number 1, then you will again try to find out what are the number of days I can shop from shop number 2. So you will get some number of days, that is 1 plus a. So let's take the count value, count 1 as 1. That means you are shopping only once or for only 1 day from shop number 1. So if you are shopping for only 1 day from shop number 1, then let's see what will be the difference in the budget. So this is your budget, and this is your cost. Now I have to shop for only 1 day. I am going to shop for only 1 day from shop number 1 because my count value is equal to 1. Now I will find out what is the remaining budget after shopping for only 1 day. So if I shop for only 1 day, the remaining difference or remaining budget will be nothing but 500 minus how many days did you shop? 1. And what is the cost of this item? It is 200. So 500 minus 200 will give you 300. Similarly here, 200 minus 1 into 50 gives you 150, means remaining budget will be 150. Now 2000 minus shopping for only 1 day, and the item cost is 500, so you will be spending 500 rupees and the remaining budget will be 1500. And now for the last item, 1000 is the overall budget and you will shop for only 1 day, so the cost of the item is 200, so you will be getting remaining 800 is your remaining budget. So this is the remaining budget after shopping for 1 day from shop number 1. Now let's try to find out for how many days can I shop from shop number 2 with this remaining budget. So my remaining budget appears to be this. Okay, and now we know the cost of the items from shop number 2. So now let's see for how many days can we survive. So the number of days, or let's say the count 2 value, will be nothing but it is going to be minimum of the number of days I can buy an ith item. So let's see for how many days can I buy this ith item. So that would be 300 divided by 100. So I can buy this item for 3 days. Now for this one, it would be nothing but 150 divided by 100. So I can buy this item for 1 day. Decimal will not be considered because integer division. Now for the third item, how many days I can buy the third item? 1500 divided by 400. This gives you 3 days. And last item, how many days or how many days can I buy the last item? 800 divided by 500. This gives you 1. This is giving you 1. Now minimum of all these values. So this means that with this remaining budget, if I take the minimum of all these values, so count 2 comes out to be 1. What this count 2 indicates? It indicates that with this remaining budget, I can buy items for 1 day from shop number 2. I repeat again, this count 2 suggests that with this remaining budget, after shopping from shop number 1, with this remaining budget, I can buy all n items for 1 day from shop number 2. Now what is the value of count 1 and count 2 in this case? Count 1 was also 1 and count 2 is also 1. So the summation will be 2. So here comes one of the answer, that we can survive for 2 days in this manner if we buy if we buy from the first shop for 1 day, and if we buy for one more day from the second shop, then we can survive for 2 days. But I want to find something better than this. So this is one of the answer. So imagine that you have your answer variable, which was initially initialized with something very small, and now it will be equal to 2. Let's imagine it is 0. Now it is equal to 2. Now again try to find different value of count. So earlier I selected count 1 was 1 day for shop number 1. Now let's say if we go for 2 days shopping from shop number 1, then we'll find out what is the value of count 2. Okay, so now let's say what if we go for shopping 2 days from shop number 1, then what is the remaining budget? So similarly again I will try to find out the remaining budget after shopping for straight 2 days from shop number 1. So the remaining budget will be something like this. Okay, so I'm shopping for 2 days. So what will be the remaining budget? So it would be 500 minus 2 days and the cost of the item is 200. So this will lead me to 100 rupees remaining. Now for the second item, so 200 minus 2 into 50, so this gives me 100 rupees remaining. So I'm buying these items for 2 days, so the cost will be multiplied by 2 for each item. So that would be 2000 minus 2 into 500, so I will be left with 1000 rupees for the last. And now let's say for the last item, 1000 minus 2 into 200, so I'll be left with 800 rupees if I buy all items for 2 days from shop number 1. Now let's try to find out count number 2. Okay, so this is my remaining budget. Now I have to find out for how many days can I buy from shop number 2 with this remaining budget. So what are the cost of items of the shop number 2? Here it is. So now here what I'm going to do, I'm going to find out the value of count 2. Okay, so count 2 is nothing but again minimum of all the divisions that you will be doing. So I will be finding out for how many days can I buy this item. So 100 rupees are remaining, so 100 divided by 100, so I can buy this item for only 1 day. Now for how many days can I buy this item? So I have 100 rupees remaining and the cost is also 100, so I can buy this item for only 1 day. For how many days for this item? So we have 1000 rupees remaining divided by 400, so this will be around 2 days. And for how many days this item can be bought? So it is 800 divided by 500, so I can buy this item for only 1 day. So your count 2 comes out to be that you can go on shopping for only 1 day from shop number 2 if you have shopped 2 days from shop number 1. So the value of count 1 and count 2 comes out to be count 1 plus count 2, means how many days are you able to buy all and items? That would be 2 plus 1 for 3 days. Now answer was earlier what? It was 2. Now answer will be updated with a larger value and hence the answer becomes 3. Answer becomes 3. Now what I will do, I'll try to again see that what if I go more days shopping on shop number 1. That means you will be thinking that let's go with count 1 value equal to 3, but that won't be possible. Why? Because see, for the shop number 1, if you entirely depend upon that shop and you go with the initial budget, then you can only shop for maximum 2 days. You cannot shop for 3 days. Why cannot you shop for 3 days? Because all items needs to be bought similar number of times. On 1 day, if you are buying one item, then you are supposed to buy all the items one time. Then for the second day, all the items one time. Then for the third day, you won't be able to buy, because here you can see the first item will get exhausted because it is costing 200 and your initial budget is only 500. So you can buy this first item for maximum 2 days only. So your count 1 cannot be increased further, and count 2 and count sorry here is the count 1. So count 1 cannot be increased more than 2 because all items will not be able to bought for more than 2 days. So this is the maximum answer that you get. Okay, and answer comes out to be 3. Now let's see the implementation, and implementation will clear all the understanding. So let's move to the implementation part. So here is the implementation part. So what I have done, so here is the stock up function, cost 1, cost 2 and the budget. Now I'm trying to initialize this mn1, minimum number of days you can buy groceries from the first shop only, and minimum number of days you can buy groceries from the second shop. So initialize with very large value 10 to the power 9 and n is extracted over here. Now what I'm going to do, now I'm going to basically find out mn1 and mn number 2. Now I'm iterating over all the items and their budget, and if the cost of ith item is greater than 0, then and only then I'm considering, because if cost of ith item is 0, then you can buy it infinite number of times, so you don't need to consider the number of times it can be bought to calculate mn1 and mn2. Now if cost of ith item is non-zero, then what I will do, I will find out for how many days this item can be bought. So that would be budget of I divided by cost 1 of I. Similarly, for shop number 2, budget of I divided by cost 2 of I. So that's what we have calculated over here. So this was for mn1. So minimum of this all values 2, 4, 4, 5. So it came out to be 2. So you can find mn1 and mn2 by doing a single iteration on budget array and dividing budget of I by cost 1 of I and budget of I by cost 2 of I to find mn1 and mn2 respectively. So that has been done in this part, in this for loop. Now just buying from a single shop is not the best strategy, as we saw in the first example. We need to mix the purchase. So from both the shops, to extend the total number of days, I will go on shopping. Now count 1 can have values from 0, 1, 2, 3. So these are different days I can buy items from count 1. Try different number of days we shop from only the first shop, and similarly you will try to find out for a particular count 1 value. Let's say count 1 is 1, then you will find out count number 2. That is, we need to find out number of days we can shop from second shop, and you are supposed to maximum count 1 and count 2. Now here imagine, so here you imagine that if mn1, That means number of days you can shop from only shop 1 is less than number of days you can shop from only shop number 2. Then what happens? You have to iterate over minimum value or mn1. So let's start with this, and let's not first confuse by what I've done in the else part. For let's say for the first shop I can go on shopping for mn1 maximum number of days. So maximum number of days I have initialized with mn1. Now I will find maximum number of days with budget, cost 1, cost 2 and mn. Now try different values of count 1. We know what is count 1. Count 1 is basically how many days I will shop from shop number 1. So count 1 will be from 0 to mn for shop number 1. If you go for count 1 number of days shopping, then there will be some remaining budget affected. So now this part is being responsible for handling this iteration that we did. So count 1, if you say count 1 is 1, that means you have shopped for 1 day from shop number 1. So your remaining budget will be this. And with this remaining budget, you will go on finding count number 2. So count number 2 indicates that for how many maximum number of days you can shop from shop number 2, given that you have shopped for 1 day from shop number 1. So that is your count number 2. So that would be applied on remaining budget. Okay, so I have done both these things in the same for loop. That's why it is very compact and has got a very small code. So I'm iterating on different values of count. Now initialize count 2 with very large value so that it can get you minimum. Now I'll iterate over all the n items, and if the cost of ith item is greater than 0 for shop number 2, then what I will do, this is the remaining budget for ith item. Budget of I minus count of 1 into cost 1 of I divided by cost 2 of I. That means for how many days this ith item can be bought from shop number 2. Okay, so you will get some value and you have to minimize count number 2 to get the value, and then you update the maximum days. Maximum days earlier was mn, which you have kept over here, and with count 1 plus count 2 compared with maximum days, and then you return the count maximum days. Okay, so that's it. So here we are just doing a very brute force greedy approach, or let's say we're just trying to optimize our greedy thinking, that we will be mixing all the possibilities and trying to get the answer. We cannot, this is similar to a fractional knapsack if you have done, because at that time when you solve fractional knapsack question, you don't directly depend upon the value of the item or the weight of the item. You try out both the parameters of the item, that is value and weight. So here also you try out both the parameters. You try to keep shop 1 into consideration and shop 2 into consideration to maximize the total number of days. Okay, now let's submit it. So it's very straightforward. The time complexity will be, if you see here is a for loop iterating n number of times, and here also you have 2 for loops going on. So that would be mn into n would be the time complexity. That means minimum value. So this is going to get accepted, and this was your question supermarket. I hope you understood this question, and now let's move to the next question. Okay, so now here is the third question. It's a very interesting question, and it is also just like the previous one. It is a variation of one of the standard problem. Okay, so let's move to the third question and understand what this third question is trying to say. So the name of the question is delivery team, and given a delivery team with D delivery boys is assigned to deliver food packets to n houses in a colony. The houses are located at positive integer coordinates on a 1D number line, and multiple houses can be at the same location. Okay, so each delivery boy starts at origin 0 and follows these rules. Picking up the food takes 1 second, movement takes 1 unit 1 second, and delivery time takes 1 second. So if a delivery boy starts from the origin, picking up the food from origin takes 1 minute, and delivering at that let's say any position of the house takes 1 minute, and the distance he will be traveling will be 1 unit per second will be the cost. Okay, so here is the time given by delivery time required by the boy. Now the team has exactly n food packets and n houses are to be delivered. Their goal is to deliver all the packets to each house in the minimum possible ways. So it is to find out that in what possible ways he can, or let's say the delivery team can deliver all the n houses. Okay, so based on the problem statement, I would like to first of all write down. Okay, so now based upon the problem statement, first of all, as this is a lengthy problem statement and it's got so many parameters just like the previous one, I would like to write down all the important pointers of the question. So the name of the question is delivery. So first thing that has been mentioned is time taken for delivery. So time taken to deliver an ith house. Okay, so time taken will be nothing but time taken by a delivery boy to deliver any house. So this is nothing but 1 unit for picking up the food. Then it will travel to that house. So it will travel 1 unit per 1 second. So this is the time required for the movement, and for delivering 1 second is required. So this is the time taken by delivery boy to deliver to that house if he starts from any position. This is the time. So movement plus pickup plus delivery. Okay, so how many delivery boys do we have? We have D delivery boys. Now apart from that, what other important things do we have? So it says that everyone starts at zero origin. It starts at origin, that is 0. Now how many packets are there? So we have n food packets and we have n houses. Okay, and each house is located at some coordinate. Each house has coordinates, okay, on the number line. And what is your target? So you are supposed to find out minimum possible time to deliver the packages. Minimum time for the packages to all the houses. So for every house we have a packet, so that means there are n packets and n houses. Now let's take the first test case, and let's try to find the answer of the first test case. So the first test case, so the house coordinates are given in the house array. So here we have 3, 4, 5 and 9. And how many delivery boys do we have? We have 2 delivery boys. So these houses are located on a 1D number line. Okay, something like this: 0, 9 and 10. So let's imagine the green dots are the houses. So at location 3 the house is present, and at location 5 the house is present, and location 9 the house is present. Now let's try to see, can we have negative values in the number line? No, we don't have a negative value because the house of I is a positive integer. So no house will be at origin also, and a house can multiple houses at the same index can be possible. And 4 is also the house. Here also we have a house. Okay, so now here it is saying that the answer of the first test case says that he needs, or the D delivery boys needs 11 seconds to deliver to all the n houses. And how this answer came out to be, so in the explanation part it has been mentioned that, okay, let's imagine that the first delivery boy starts from this location. Okay, and this delivery boy will be utilized as much as possible. Okay, so what he will be doing, he will be given 3 food packets. So to pick up the 3 food packets, he will be required time 3 units. Then what will happen, he will reach this house. So the time required will be 3 units, because from origin it is at a 3 unit distance. So currently I am also writing down the time that has been spent so far. So now time will be 3 for picking up, so 3 seconds, and now 3 for traveling. So currently the time says 6 seconds. Okay, now 6 second, and at 6 second he will reach over here for to this house and he will deliver. So +1 for delivery. So 7 seconds have been exhausted. Now from 7 second he moves to the next house. So 1 second is required to move because it has a distance of 1. So 7 plus 1 will give you 8 seconds elapsed, and now he will deliver it. So 1 over here, so you will have 9 seconds elapsed. Now he will move to the next house at a distance of 1. So 9 plus 1 gives you 10 seconds acquired, and now he will deliver to this house. So 10 plus 1 will be 11 minutes have already expired. Now what he does, he keeps only one delivery boy to deliver the first 3 houses. Now what he does, while this first delivery boy was delivering to all these 3 houses, he also simultaneously sends another delivery boy at the same time. Means time is common for all the delivery boys, right? So here you are not supposed to find out the sum of time, you are supposed to find out the minimum time. So clock is common for everyone, and now clock is already at 11 seconds. Now in this 11 second, what amount of time would have this delivery boy taken in order to deliver this house? Why only this house? Because these 3 have already been delivered by this first. So while this first one will be traveling from here to the last house, this were already delivered by the other delivery person, so he will not waste his time to deliver, because picking up their food and delivering also takes one unit of time respectively, right? So what he will do, the first delivery person will pick up the so-called food packet for the last one. Okay, so the time here is common only. Okay, so time is already 11 seconds, so it is not beyond 11 seconds. So in 11 seconds this time can be elapsed on this delivery person can pick up, because it only needs 1 second. So when time would have been 1 second, so this and this, both of them will be working simultaneously. So now he'll travel a distance of 9 units because he's at origin. So the time required for this one will be 1 plus 9. So again the time is still 10 seconds, and delivery person 1 has already elapsed 11 minutes. So in the 11 minutes, delivery person second can also reach to this house. right? Because it only needs 10 seconds to reach the house and pick up the food. Now when he reaches the house, one more second will be required to deliver the last house, right? So the time will be increased by 1, and now the total time required for the first one to deliver this house is also 11. It is not beyond this. So in 11 minutes, both the delivery boy were working, and they have delivered all the n houses in 11 seconds. So the output comes out that the minimum time required for both, or let's say D delivery boys, to deliver n houses comes out to be 11. Okay. So here the logic becomes a little complex when we think about the time, right? Because time is to be considered as common value between all of them. Now how can we solve this question? So now let's try to think about the approach. So if I want to give you an approach in a single line, so single line approach would be that if all the delivery boys are working efficiently at their maximum limit, then the time limit can be minimized, or the time required to deliver all n houses can be minimized if all the delivery persons are working to some boundary of time. So what I will be doing, so here we are not sure about the time required, right? We are supposed to find out a common time for all the delivery persons. So what I will be doing, I will be basically applying a binary search on time. Straightforward. I don't know what is the exact value of time. I have to minimize time. So binary search can be used to minimize some factors. I can minimize time over here. So whenever we talk about binary search, you will be thinking about what is the search space of time taken to deliver all the n houses. So here there would be some lower value and there would be some higher value. So imagine that I am not sure about the higher value, because you can take infinite amount of time and get deliver all the houses, right? So I would take a very large value, that is something near about 10 to the power 16. And what about the lowest time required? So the lowest time, if you pay attention, the lowest time would be taken by the house that is farthest from the origin, plus 2. So here you can see this house is the farthest from the origin. Now any delivery person, if he wants to reach over here, then he would need 9 plus 2, that is 1 for pickup, 1 for delivering, and 9 for traveling this distance from origin. So 11 seconds are required to deliver this farthest house. So in 11 seconds, don't you think all the other delivery persons can deliver the rest of the houses? Yes, definitely they can deliver. If in this 11 second other delivery persons are also working to deliver all these houses, then obviously the time taken for one delivery person from origin to deliver to this house would be lesser than 9 plus 2, because it would be 5 plus 2, and for this one it would be 4 plus 2, and for this one it would be 3 plus 2. So even though if you have one delivery boy for every particular house, then also the lowest time would be this. It cannot go beyond 9 plus 2. Okay, it cannot go beyond 9 plus 2. So that's why I have taken the lowest time required for delivering as 9.2, 9 as 9 plus 2. It can be, but it can be greater than 9 plus 2 in some scenarios. So that's why I have taken the lowest value as the maximum or the farthest house plus 2. So mx is the maximum value. So how will you get this maximum? So you will be basically sorting, because they are based on the number line, and on the number line they will be in sorted positions. The coordinates will be sorted. Okay, fine. So now let's try to think how we can solve it. So by far I have given you an idea about that. We'll apply the binary search on time taken, and we'll try to minimize the time taken. Okay. So the lowest time can be maximum plus 2, and the highest time can be 10 to the power 16. Now I have taken the lowest time as mx plus 2. So you might be wondering that, okay, lowest time is mx plus 2, and sir is saying that it can be greater than mx plus 2. So can you just give me an example for what kind of test cases the lowest time will be greater than maximum plus 2? So the example or the confusion to your doubt can be answered if you manipulate the number of delivery boys you have. So let's say we have currently 2 delivery persons, and now let's say if you have one delivery person, then one delivery person will take more amount of time. How more amount of time? Because if you see what happens when one delivery person goes on delivering all the n houses, so he will start from the first house. Now it has to deliver all the houses, so he will try to get the pickup of all the food from the origin. So it will cost him 4 seconds. Now it will go to this first house at third coordinate. So now the time would be 3 seconds more, because he does some movement. Now he delivers it, so that would be 1 for delivering. So 4 plus 3 gives you 7, 8. Now from 8, 1 more second is required to reach this house, so plus 1 over here, and now to deliver plus 1 over here. So for this house till now he has given around 3 plus 3 6. plus 4, 10. 10 seconds have already elapsed. Now he moves to the next house in 1 more second and he delivers it for 1 more second. So 12 units, 12 seconds has been acquired, and now he moves to this house. So what is this distance? 9 minus 5 is 4. So 4 units for the distance coverage, and now for delivery, one more. So you can see the answer is 17 seconds minimum are required to deliver all the n houses when d equals to 1. So now you can see maximum, that was 9 plus 2 was only 11. But if you have less delivery persons, then the time can be greater than the last one. Then it can be greater than mx plus 2. So that's why I have taken the lower value as mx plus 2 and higher value as infinite. Okay, because it also depends, the time also depends upon the delivery person. So you should not be forgetting about the value of d while calculating the time in binary search. Okay, so this was the example that justifies that, okay, we can have answer greater than mx plus 2. Now I will be applying binary search on this mx plus 2. Okay, so how will we be able to apply binary search? So I'll show you this entire binary search for a very short search space, and I will try to solve for this given example. Okay, so we have two delivery persons, and we are applying binary search to find out minimum time taken. So binary search will be applied on the lower value, that is 9 plus 2, maximum of this first house. We'll be sorting this house array to get all the houses aligned according to the number line. So 3, 4, 5, 9 will be what we have. So 9 plus 2 will be 11, that would be the lowest value. Then you will have, I'll take 11 to 20 in this case. Okay, 11, 12, 13, 14, 15, 16, 17, 18 and 19, and this is, let's say, the highest value. Now what I will try to do, let's imagine that minimum time required by d delivery persons to deliver n houses is mid. So that is 11 plus 20 divided by 2, you will be getting somewhere around 31 divided by 2, you will be getting 15. So what I want to do now, I want to say that, what is it possible for d delivery persons to deliver food to n houses in mid amount of time? So I'm saying that verify, or let's say verify if it is possible by d equals to 2 delivery person to deliver all n houses within mid equals to 15 seconds. Is it possible or not? We have to verify. So here we need a helper function that can help us and get an idea whether we can whether in 15 seconds with two delivery person we can deliver all the houses or not. Okay, so let's try to validate. So now I'll be check when your time, or when your time constraint is equal to mid equals to 15, and you have all the houses aligned, and you have d equals to 2 delivery person, can you deliver all the houses? Okay, so now here, how we'll be able to know that how many houses can a particular delivery person deliver within 15 seconds? We are not sure. So what we'll be doing, we'll be starting with one by one delivery person. We'll start with first delivery person, and we'll see that in 15 seconds how many houses first delivery person can cover up. Then I will see that, okay, these are only the houses, they are less than n houses covered, so I'll include one more delivery person, and I will see that how many houses can be delivered by this second delivery person in 15 seconds. So what I'm trying to say is that, so what we were doing when we were trying to get the answer, that's what exactly we'll be doing. Okay, so what I will do, first of all, I will take a delivery person, and I will see that in 15 seconds I have a limit. Now you have a limit on time, that your delivery time is 15 seconds. You have to deliver in 15 seconds. Can you do it with two delivery person? So I will start with the first delivery person, and I will see in 15 seconds how many houses this delivery person can deliver. Okay, so if you see that how many houses that delivery person can deliver, so let's see, he starts from origin. Now don't think about how many pickups he has done from origin. We'll include the pickup when we reach a house. Okay, so this is the count of the delivery person. So we are considering the delivery person 1, and the sum or the time required to deliver for now. Okay, for this first delivery person, what is the current time required for delivering the houses? It is initially 0. Okay, and we'll also put the idea about what is the current position of the delivery person. So he is starting from 0. Delivery person 1 has spent a time of 0, and he's starting from current position 0. Now you see that one house is located at position equals to 3. Now to deliver to this house, what is the time required? So time required will be nothing but the position of the house minus current position of this delivery boy. So he'll be at position 0. So this is the moment required, and plus 2 for pickup and delivering for this house. So time required will be 5 units for this house. So can this delivery person deliver this house in 15 seconds? Yes, because to deliver this house he only needs 5 seconds and we have a limit of 15. So you will say, okay, so this house has been delivered by this first delivery person, because the value of time required to deliver and the time spent by this delivery person, that is sum, is the time spent by the delivery person. Current delivery person is 0. So this value should be less than or equal to mid. Okay, so time for current house is 5 seconds and the time spent by the delivery person so far is 0, is less than or equal to 15. Yes. So this means that your delivery person will be now standing at this location. He is currently at this location. So your current position for this delivery person should be changed to 3, and the time spent by this delivery person will be what? It will be whatever was the previous value plus time required to deliver this current house. It is 5. So 0 plus 5 gives you 5. So time spent by this delivery person is 5 seconds. Okay. Now what you will do? You will again try to go to the next house. Okay. You will again try to see that can this delivery person deliver the next house or not. So you will see in the houses array, next house is located at position number 4. Now to deliver at this position for this delivery person, what is the time required? So that would be, what is the position of the house? 4. What is the current position of our delivery guy? It is 3 plus 2 for pickup and delivery. So that would give us 3. Okay. So time required to deliver this house at index 4 is 3 units. Now thinking about the time already spent by the current delivery person, it is what? It is 5, and time required to deliver this house is also is what? 3. Is this less than or equal to bound 15 seconds? Yes, 8 is less than or equal to 15. So yes, this delivery person can also deliver to this house within 15 seconds. Okay. Now your delivery person will be at this house, so his location current position will be 4, and the time spent by him will be what? Earlier he had spent 5 seconds. Now for this house he needs to spend plus 3. So 5 plus 3, that is 8 seconds have been spent by this delivery guy. Okay. And now we'll try to see the upcoming house can be delivered by current delivery person or not. Okay. So what I will do, I will go to the next house and I will see what is the position. It is 5. Now time required to deliver this house will be what? So position is what? 5. And what is the current position of our delivery person? It is at 4. So plus 2 for pickup and delivery. So 5 minus 4 plus 2, that would be 3. So 3 unit time is required to deliver at this position. Now can this current delivery guy deliver this house or not? So time required to deliver this house is 3 units and the time spent so far is 8 units. So 8 plus 3 is less than or equal to 15 seconds. Can he deliver this house as well in 15 seconds? Yes. 8 plus 3 is what? It is 11. So 11 is less than or equal to 15. So yes, this delivery person will be utilized to deliver food to this house as well. So he will go to this house. So his current position becomes 5 and time spent gets increased by 3. So 8 plus 3 gives you 11. So the time spent by this first delivery person is 11 so far. Okay. Now let's try to see, can he go forward and deliver to the next also? So let's say, can he deliver this next house? So I will try to see what is the time required to deliver this next house. So position of this next house is at 9. So time required to deliver this house by the current delivery guy is what? It is 9 minus 4 or 9 minus 5 for the moment. This is 4 distance plus 2 for delivering. So 9 minus 5 is 4. 4 plus 2 is what? 6. So 6 unit is required to deliver this house located at 9th index. Now this delivery person, current first delivery person has already spent 11 seconds, and if he goes to deliver this house he will be requiring 17 seconds, but our time limit has been bounded with what? 15. So this is not delivered or deliverable by this first delivery guy. Okay, because time required to deliver this house is going beyond our expected time, that was 15 seconds. So what I will do, I will assign one more delivery guy. I will take into consideration one more delivery person. Okay, and this first delivery person, I will say you are supposed to deliver till this point only, and for the other houses I will assign someone else. Now when you assign someone else, he obviously will be starting from the origin only. right? He will be starting from origin, and he has to deliver this house. He has to deliver this house. So now, guys, tell me, if this second person was starting for origin and he was supposed to deliver to this house, then what is the time spent by this delivery person? Okay, so the time spent by this delivery person will be something that would be position plus 2. So position of the current house that I want to deliver is 9. Now time required by the new delivery person to deliver this house would be what? It would be the movement required, right? So position is 9 and he's starting from 0. The new delivery guy is starting from 0. Okay, so the count says which is the delivery guy. He's the new delivery guy. And what will be his current position? His current position initially will be 0. So he'll be starting from 0. So 9 minus 0 plus 2, that would be 11. Now what is the time spent by this new delivery guy? It is 11, right? So for the previous guy it was 11, and now here also he's spending 11 units, and he started from 0th position, so that's why he needs 11 minutes. But our time will be limited to 15 seconds only, so this 11 is less than 15, so he can obviously deliver this last house as well. Okay, so your count, sum and current position will be reinitialized. So sum will be initialized with what? It will be initialized with time, that is, what is the current house position plus 2, that is 11. So sum will be 11 and current position will be changed. Now current position is for this delivery guy, so this delivery guy will be delivering this house, so his position will be what? His position will be 9. Whatever is the position of the house, that would be the position, that is 9. So now I have reinitialized all the variables, and if there were further more houses, then you would have considered this delivery guy to deliver to those houses. Okay, and if those houses were not deliverable by this delivery boy within the time limit, then you would take one more delivery person and you would again start from origin and make that delivery person dedicatedly to that house which was not deliverable by this delivery boy. Okay, now let's say the implementation, and implementation will give you more idea on the same. So here is the implementation. So what I have done, first of all, I need to sort the houses according to the positions. Then what I have done, I have taken the maximum time required. I need to get the maximum value from the house, maximum, let's say the farthest house index or position. That would be the maximum value from the sorted house array. Now I'll have a search space of time that is from mx plus 2 to 1 to the power 16, very large value. And let's imagine result is equal to high for now. So I will start with low equals to mx plus 2 and high equals to 1 to the power 16. Now I'll apply binary search, and now let's restrict our time to mid. Now I want to check if deliveries can be completed within mid amount of time with D delivery boys, yes or no. If yes, then what I would do, I would update my result and I would try to minimize the value of time. So I would bring my high to mid minus 1. If it is not deliverable, then what I would do, I would try to increase my time. So I would move my low value to mid plus 1 and then try to find the answer. Now let's see what this check is going to do. So check is going to check whether you can deliver all the houses in mid amount of time with D delivery boys or not. So let's start with one delivery boy and see how far it can deliver within the mid time. So count 1 indicates the delivery person, first delivery person or number of delivery boys, and sum is equal to total time which is spent by the current delivery, and current position means where is this delivery person standing right now. It is starting from 0. Now I will iterate over all the houses. Now I will see what is the time required to deliver the ith house. So position minus current pose is the moment required for that delivery person plus 2 for pickup and delivery. Now I will check if the current delivery person can deliver this house or not. So time spent by the delivery person plus the time required to deliver the ith house is the total time required or total time spent. So sum plus time is less than or equal to mid. It should be less than or equal to 15. Yes, then sum, basically this delivery person will be delivering to this new house, and then you will update the current position to this position, because you will bring the delivery person to that new house which was delivered in this iteration. Now suppose if the delivery person is not able to deliver this house, then what will happen? Your sum plus time will be greater than mid. So you need to assign a new delivery house or a new delivery boy for the houses from current position to the rest of the position. So you'll increment the count value. Now for this new house, we have seen for this new house, what was the time required to deliver? It was nothing but position plus 2. So the time required to deliver this new house is position plus 2, because the delivery guy is starting from origin. And what is the time spent by this new delivery person? It would be same as the time required to deliver, right? Because he started from origin, and in the between he has not delivered anyone else. He was justified to deliver for this house only. So your time spent by this new delivery person will also going to be position plus 2. And in this manner you will try to find out that within mid amount of time how many delivery boys are required at minimum. Now sometimes it's possible that the delivery boys count would be greater for some mid amount of time. In that case we cannot deliver all the houses in mid amount of time, because we have only delivery boys. So if your count of delivery persons required to deliver all houses in mid amount of time is less than or equal to D, then yes, you would say that all houses can be delivered by D delivery boys in mid amount of time. Because here you have two things to keep in mind: mid as well as the delivery boys that you have. So in this manner check will return true or false, and based upon that your binary search will give you the minimum value and result will be returned. And let's try to submit it and see what do we get. And we can see that it has been successfully submitted. So talking about the time complexity, it would be, so this check function will be iterating for all the mid values, and check is having a simple for loop iterating over all houses. And this while loop will take log of 10 to the power 16. So the time complexity would be n into log of 10 to the power 16. Somewhere around that will be your time complexity, and space will be constant. I'm not using anything extra. So that is the time and space of this question delivery team.